Welcome to Zip and Enumerate lecture. So Zip can combine elements from two or more lists into nested tuples. And then Enumerate can generate an integer number next to each output. And ultimately, both of these can easily be replaced with an extra bit of code. So the usage of both Zip and Enumerate, particularly Enumerate, is somewhat questionable. Okay. So we'll start off with Enumerate, which is the more simple of the two. So we do, let's say, for I in range, let's say 10, 40, and we'll increment by 5, colon, print I. As you can see, we have the output of 10 to 35 incrementing by 5 each time. So it's a pretty straightforward for loop. And then let's say we use the enumerate. Well, what we do is the enumerate is wrap around the range, and then we do, let's say, counts. Could be anything, it doesn't have to necessarily be counts. And then you have 0 to 5. So the 0 to 5 is the enumerate output, and the 10 to 35, of course, is the range output. And we could also change this to, let's say, 200. So we have 200 to 205. And note that it's counting sequentially from 0, 1, 2, 3, 4, 5. So we can change the initial number, but not the inner number. It's always going to be incrementing by one number at a time. Okay, so how can we create the equivalent without the enumerate? Because as I stated above, both the enumerate and the zip can actually easily be replaced with a little bit of extra code. Well, all we have to do, and this is probably actually less code, is say for I in range, the same as before, so 10, 40, and then incrementing by 5, colon, print I, we've got the output as before, and then let's say we do 190 plus I, and it's not quite the same as the enumerate, but it's a reasonable approximation. Okay. So moving on from the enumerate, that's pretty much done there. We'll go on to the zip, which is the main focus of this lecture here. And that is, we do tup1, it's going to be a tuple. We'll do 33, 49, and 55. And then we'll do a list as well of my list equals, say, 10, 20, and 30. And then we'll do z as the variable for the zip. And we'll do zip tup1 and my list, and then if we do z as the output, as you can see here, what we have is zip, and then it's saying where in memory the zip is located, but that's not very useful to us. So let's say we put our list around it so we can actually see what's happening. And as you can see here, we have nested tuples. In this case, we have 3 nested tuples. And what's happened is that we've had the, say for instance, the first index, so 33 and 10 from both tup1 and my list in this nested tuple, and then the second time with 49 and 20 for the second nested tuple, and then 55 and 30 for the final nested tuple. Okay, and if I were to do type z, we'll just get, of course, the list. And if I were to just change that, we get zip. Okay, so I'm just going to put this back into a list so we can use that. Well, actually, it's not entirely necessary to have it as a list here. When we're using a for loop or while loop, it's not entirely necessary. Much like in the same way if we were to do range, say 0, 5, we don't get any output, but we can still use this with a for loop or a while loop. When we just do list, we're just simply able to examine the elements within the range list. Okay, so moving on from that, we're going to use that now, and let's say we do for t m in z colon print t plus m. And we have 43, 69, and 85. So we're adding all of the elements from both the tuple and the list together to generate these 3 numbers that we've calculated. So how can we do the equivalent without the zip? Well, it's quite straightforward. What we have to do is for I in range 3, because we have 3 elements within both the tuple and the list, we can do print tuple1 I plus my list I. And there you have it, the exact same output of 43, 69, and 85. Okay, so moving on from that, let's say I just scroll down first and we can do 2 lists. We'll do groceries equals apples, chips, bread, and ice cream, and then we'll do the prices respectively for each of these items. So we'll do just as integers 2, 3, 1.2, and let's say 4.25 for ice cream, which I think is a reasonable price. So we do for food in range 4, because we have 4 elements in both of these lists, colon print groceries food, we'll do comma equals prices food. And there you have it. So apples equals 2, chips equals 3, bread equals 1.2, and ice cream equals 4.25. So we could do the same with a zip, which is somewhat more laborious though, because we have to do another line of code here. So the usage of zip is somewhat questionable, but it does shine later on in a moment. So just do list zip groceries and then prices, and we'll do zip shop. As you can see here, we have the nested tuples for the strings and for the integers, and then we do for gp in zip shop colon print g equals p, and there you have it. You have the exact same output of apples equals 2 all the way to ice cream equals 4.25. Okay, as you can see here, we didn't have to use this zip necessarily. We could actually just remove that list and we still get the same output. Alright, so moving on from that, let's say we do num1, so it's 2 new lists in this case. So num1 equals 100, 2, 90, and 10, and then do semicolon to keep it on the same line. Num2 equals 12, 7, 90, and 50, and then we'll do zip num equals zip num1, num2, and then we'll do for I, j in zip num colon if I greater than j, see, j colon print I, elif I less than j colon print j, else print I j if they're both equal to each other. And there you have it. So you have 100, 70, 90, 90, and 50. Now we have 90, 90 printed out because for I and j, both num1 and num2 have the number 90 shared between both of these lists. Hence we have 90 printed out twice here in this line of code. Okay, so how would we create the equivalent without the zip num, without the zip? Well, what we can do is pretty straightforward. So essentially what we can do is for I in range 4, because of course we have 4 elements in both of these lists, num1 and 2, if num1 I is greater than num2 I colon print num1 I elif num1 I is less than num2 I colon print num2 I else colon print num1 I, num2 I. We run that, and as you can see, we have the exact same output of 100, 7, 90, 90, and 50. Okay, great. So moving on from that, let's say we do our last example of numbers equals list range 10, 70, and 10. And then we do numbers, and as you can see, we have 6 elements, incrementing by 10 each time, so 10 to 60. And then we have values. In this case, we only have 2 and 5, so we only have 2 elements, whereas these have 6. So in this case, compared to the previous examples, which had an even number, or rather an equal number of elements for both lists, in this case we have an unequal number of elements between these two lists. So this is going to be somewhat problematic if, say for instance, if say for instance I wanted to multiply each of these elements in numbers by 2, and also multiply each of these elements in numbers by 5. So that would give a total of 12 elements, because we have 6 here at the moment. That's somewhat tricky, and if we were to just do it the basic way that we did before with the previous logic that we've applied to this issue of, let's say we have calc equals, and we do, let's say, n in, let's see, range, let's do range len numbers colon, and then we'll do s equals in fact I'll just leave it as that, n okay, what can I do here is numbers n times values n, and then I'll do calc.append s, and then do calc, and as you can see here we have an index error, and the reason for that of course is because where it says list index out of range, well, we have one of them, numbers, which has 6 elements, and the values has 2. So we have a bit of a problem here. Okay, so there's a way to remedy this potentially, and that is if we were to simply delete this code here for starters, and we do the zip. So what we do is zip val equals list zip numbers values. We run that, and then if we take a look, zip val, well, we have a problem here as well, because we have only 10 and 20, so we only have 2 elements from the numbers list. The numbers was 10 to 60, not 10 to 20. So the problem with using zip is that it only creates these tuples, these nested tuples, the number of them based upon the lowest number of elements in the smallest list. And in this case, we only have 2 in our smaller list. So a way to remedy this problem is to import iter tools. And we run that, and then we check iter tools dot tab. And as you can see here, we have all of these functions and methods that we can apply to our code. And the one that we're interested in is cycle. And what we can do, instead of importing it that way, is we could do from iter tools import cycle, or we could actually rename cycle as, say, sci. Okay. And now, if we apply sci, and this should be fine, just check if we've got enough parentheses here. So free here and free here. Okay, that should be fine. And if I run this now, as you can see, we have a total of 6 tuples, because that's the same number of tuples that we have, or rather elements we have within the numbers list. Alright, so we can give this a try now with our for loop. So if we were to try a for loop of for nv in zip val colon s equals n times v cal c dot append s, and then we do cal c. So we're somewhat there. We've only got 6 elements still within our list, and we want a total of 12, whereby the 2 and the 5 are both calculating or both multiplying each of these elements. So 2 would be multiplying all of these elements here, and 5 would also be multiplying each of these elements here. So we want a total of 12 elements within this cal c list. So how will we go about that? We still haven't quite achieved our desired results. Well, what we can do is simply, let's say we ignore this values, and then instead we'll create val1 equals 2, and create on the same line here. Let's just delete that. Val2 equals 5, and then change this to val1 and put another one here of psi val2, and then we'll do z's, and then we do t equals n times z. So n is going to be for the numbers elements, v is going to be for val2, which is number 2, and then z is going to be for the element 5. Okay, and then what we have to do is another append, cal c dot appends t. And we run this. As you can see now, we have a total of 12 elements. If I were to do len just to double check, we have 12. Okay, great. Just comment that out. So let's just double check here. We scroll down. So what's happening is that if I were to just run that again, so we have zip val, and we have a total of 3 elements within each of these tuples. So what's happening is that the numbers has got, of course, 10 to 60, and it's multiplied each time. So 2 times 10 is 20, 5 times 10 is 50, and you have these 2 values here. Then in the second tuple we have 20 from the numbers, and then 2 times 20 is 40, 5 times 20 is 100, and you have these 2 numbers. And then with this one we have 30 from the numbers, and you have 2 times 30 is 60, 5 times 30 is 150, and then from the next one, and then I'll just go on to the last one actually, and then you have 60 from the numbers, the last elements. That's going to be 2 times 60 is 120, and then 5 times 60 is 300. Okay, great. So that concludes my lecture on zip and enumerate. Hope that's been insightful, and if you have any questions, feel free to ask in the Q&A. Thanks.